Alright, in today's mini lecture we're going to be solving radical equations. So these are equations with radicals in them. They can be either on one side or maybe even on both sides of the equal sign. So before you get started, you have to know the steps to solving a radical equation. The first step is to isolate a radical on one side of the equation. After that, we apply what's called the principle of power. All that is raising both sides to what I call the nth power. And that n is just the value of the radical's index. So if it's a square root where the index is a 2, we raise both sides to the second power. If it's a cube root where the index is a 3, we would raise both sides to the third power. We then repeat steps 1 and 2 if a radical still exists, and we solve the resulting equation and then do a check. So let's go ahead and start out with a problem such as this. The square root of x is equal to 10. Alright, the first step is to isolate a radical on one side of the equation. Well, it looks to me that the radical, the square root of x, is already isolated on this left hand side, so therefore step 1 is complete. Step 2 says to apply the principle of power. Well, the principle of power I said was to raise both sides to the nth power. So what are we going to raise both sides to? Well, we look right here at the index. For this, the square root of x, there's implied to be an invisible 2 there. When there's no index there, no number there, right there inside of the radical, then there's implied to be an invisible 2. Right? So I'll even write it right now. But when there's nothing there, there's implied to be an invisible 2. So that is the number we raise both sides of the equation to, 2, both to the second power. If that were a 3 there, it would be the cube root, and we would then raise both sides to the third power as I stated earlier. Alright, so once we raise to the second power a square root, they kind of cancel each other out, and you're left with just x. And that's equal to 10 to the second power, which is 100. Alright, and then that's the resulting equations already solved, so we can go to step 5, which is the check. So I'll check it by plugging it right back into this original. So we'll plug in the 100 for x, and the square root of 100 is 10. So that gives us a true statement, so we can say yes, x equals 100 is our solution. Alright, we'll try another one, and that other problem looks like this. We have x minus, let's say 4 is equal to 3. The square root of x minus 4 is equal to 3. So let's get started. So the first step is to isolate a radical on one side. Well, this radical is the square root of x minus 4. Make sure you pay close attention to the radical sign and how it's written. Sometimes the radical may just come and cover the x, and in this case it doesn't. It goes all the way across and covers x minus 4. If they're written in a certain way, you have to make sure that you copy it down and treat it that specific way, because it makes a difference. So this one is the square root of x minus 4. So this entire radical is already isolated. Why? Because there's nothing in front of it, there's nothing behind it, there's nothing being added or subtracted to it in front or behind, and there's nothing being multiplied times it. Alright, so it's already isolated. Step 1 is done. Step 2, we apply the principle of power. So nothing is in the index, but I know that there's implied to be a 2 there in the index. So therefore I raise both sides to the second power. Alright, in raising a square root to the second power, they kind of cancel out on us, and we're left with the x minus 4 equals 3 to the second, which is 9. Alright, and now we solve the resulting equation. We don't have to repeat steps 1 and 2 because no more radicals exist. So we go down to solve the resulting equation and solve for x. So we add 4 to both sides, and we get x is equal to 13. The last step And again, this last step is mandatory for solving radical equations. It's performing the check. The square root of x minus 4 is the original problem. So all we do is plug in the 13 everywhere we see an x in our original problem. So 13 minus 4 is 9. The square root of 9 is 3. And we get 3 is equal to 3. So therefore we know that x equals 13 is a solution for us. And in doing the check, we only worry about the principal square root, and this is done by convention. All right, we'll try another example. Example 3. Example 3 has negative 8 plus the square root of 5a minus 5, and that's equal to negative 3. All right, so our first step says to isolate a radical. So if I look at this, the radical, the square root of 5a minus 5, is not isolated. We need to get it by itself on this side of the equal sign. It's not isolated because there's a negative 8 being added to it, right? We need this totally by itself. So what I'm going to do is the opposite of the negative 8, positive 8. I do it to both sides. And we have the square root of 5a minus 5 is equal to 5. All right, next I apply that principle of power. Well, the principle of power tells me that we're going to raise both sides to the nth power. So let's go ahead and do that. Raise both sides to that nth power. Well, what is the n value? The n value is the value of that index. There's implied to be a 2 there because it's a square root. So we raise both sides to the second power. So the radical, the square root, and the exponent of 2 cancel each other out as inverses. And we have 5a minus 5 equals 25. The next step says to repeat steps 1 and 2 if a radical still exists. Luckily, there's no more radical that exists here. So we go ahead and solve the resulting equation. We go ahead and add 5 to both sides, and we get 5a equals 30. We want to get a by itself, so we go ahead and say, okay, the opposite operation of this multiplication is division. So I'll divide both sides by 5, and we get a is equal to 6. The next step I need to do is my check, and in checking it I'm going to plug back into my original. So my original was negative 8 plus the square root of 5a minus 5 equals negative 3. I'm plugging that 6 back into the equation everywhere I see an a. So negative 8 plus the square root of 5 times 6 minus 5 equals negative 3. Alright, and now I'm just going to go ahead and crunch these numbers. 5 times 6 is 30. 30 minus 5 is 25. And negative 8 plus the square root of 25, is 5. And now negative 8 plus 5 is negative 3. And that in fact is equal to negative 3. It's a true statement. So therefore, I go ahead and state that a is equal to 6. All right. Alright, now I'll try another problem that looks a little bit different. This one states 10 times the square root of 9x equals 60. 10 times the square root of 9x equals 60. So, the first step says to isolate a radical on one side. Well, this radical is not isolated, this square root of 9x. Why? Because there's a 10 right in front of it. We need this radical by itself with nothing in front and nothing behind it. So what will I do? I look and I say this is 10 times the square root of 9x. I need to do the opposite, which is division, and divide by 10. What I do to one side, I do to the other side. These cancel out. When things cancel, they leave ones. So I have the square root of 9x is equal to 6. Now I go ahead and apply that principle of power, right? And in doing that, I'm just going to square both sides, raise both sides to the second power, because my index is an invisible 2. I raise both sides to the second power. The exponent of 2 and the square root symbol, they cancel each other out as inverses. So we have 9x is equal to 6 squared, which is 6 times 6, making it 36. And now I'm just solving for x, right? Because no radical still exists, so I don't have to repeat any steps again. And I'm just solving this 9x equals 36. I'll divide both sides by 9, and I get x is equal to 4. Last step is the check, which is very important. So I'll plug it back into my original. 10 times the square root of 9x equals 60. I'll plug that 4 in everywhere I see an x. I'll plug in a 4 everywhere I see an x. So 10 times the square root of 9 times 4 equals 60. So 9 times 4 gets me 36. And the square root of 36 is 6. And 10 times 6 is 60. So this is a true statement, so I know that my answer is correct. X is equal to 4. Alright, let's do one more. Last problem. Problem number 5. So this states that negative 3 plus the square root of m plus 59 is equal to m. Alright, first things first, I need to isolate my radical. So there's a negative 3 in front of it, so I need to get rid of it. I'm going to do the opposite, which is add 3. Add 3. So that gets rid of it on the left hand side, so I'm left with, on that left hand side, m plus 59, the square root of that, is equal to, and what I did to one side I had to do to the other, and we know that we can't add a number to a variable, so I'm just bringing it over to this space, so I get m plus 3. Alright, next step is to apply the principle of power. Well, the principle of power says to raise both sides, the entire side, to the nth power, the entire side. So there's an invisible 2 here, or there's implied to be a 2 because it's a square root when it's not written, so I raise both sides to the second power. So when I raise a square root to the second power, their inverses, they'll cancel each other out, and we're left with m plus 59. However, this m plus 3 squared, don't let this throw you off any. I'm going to go to the side here and work through this. M plus 3 squared. What does that mean? That means m plus 3 times itself, right? M plus 3 times m plus 3. To me, it looks like you have to FOIL. First, outer, inner, last. So we have m times m is m squared. The outer is m times 3 is 3m. The inner, 3 times m is another 3m. And then the last is 3 times 3 is 9. We combine these like terms and we get m squared plus 6m plus 9. So that's what we get on this right hand side. M squared plus 6m plus 9. So make sure you remember that when you're faced with that binomial squared, that you go ahead and FOIL, multiplying it times itself. Alright, the next thing I notice is that there are no more radicals, so we can go to solving the resulting equation. However, in looking at this resulting equation, it's not like the other ones. Why? Because I see this exponent of 2. This is the largest exponent in the entire equation. That's telling me that this equation is quadratic, right? The largest exponent is 2. It's of degree 2, therefore it's quadratic. We think back, how do we solve quadratic equations? Well, we can solve them by factoring, square root property, completing the square, or the quadratic formula. I'm going to attempt to solve this by factoring, but before we even do that, we have to put it in standard form where everything is on one side and zeros on the other. So I'm going to subtract m and subtract 59, subtract m and subtract 59 on the other side, and then we'll get a 0 on the left, and we have m squared plus 5m, and then we have minus 50. Right? Now this is in standard form. for a quadratic equation, right? Everything is on one side and zeros on the other side. So now we can go ahead and proceed to factor. So luckily for this quadratic equation, the leading coefficient is a 1, so I can go ahead and use the product sum method. If you need to review the product sum method, you'll have to check in earlier videos and you'll see the product sum method for factoring in my list of videos. So basically I'm just going to say to myself, what times what makes 50, and the same two numbers, if I add or subtract them, need to make a 5. Well, I'm thinking 10 times 5 is 50. 10 times 5 is 50, and 10 and 5, if I add or subtract, will they make 5? Yes, if I subtract them, they will make 5. So I know those two values will likely work, but I just have to make sure my signs are correct. This has to be a positive 10 and a negative 5 to work, right? Because positive 10 times negative 5 will get a negative 50, and positive 10 minus 5 makes positive 5. That's in this middle variable term. Alright, so that's factored out completely. And then the next step in solving a quadratic equation after factoring is to use the zero factor property or zero factor principle. Right, so we'll say 0 is equal to m plus 10 and 0 is equal to m minus 5. Alright, so we just solve for m. So basically here I'm just going to subtract 10 from both sides. So negative 10 equals m, and here I'm going to add 5 to both sides. So m is equal to 5. Alright, so we're almost there. We're on the last step. The last step is so important, which is to check. And please, when solving radical equations, do not forget to check. And I'm going to show you why in just a few moments. So let's look at the original problems. I'm sorry, the original problem. So we had negative 3 plus the square root of m plus 59 is equal to m. Alright, and I'm going to write it again because I have two checks to do. Negative 3 plus the square root of m plus 59 equals m. So I'm going to check the m equals negative 10, and I'm going to check m equals 5 and see if they work. Alright, so let's plug in a negative 10 everywhere we see an m. Negative 10 plus 59 equals m. And let's make this a little bit better. Alright, so negative 3 plus the square root of 59 minus 10 is 49. And I'm sorry, I need to plug in the 10 there as well, right? Because we're supposed to be plugging in 10, negative 10 everywhere we see an m. Alright, so negative 3 plus the square root of 49 is 7 equals negative 10. And negative 3 and a positive 7 is actually 4. And 4 does not equal negative 10. So therefore, I go back up here and I cross this out. And I point at that, and I'm going to show you what it's called. It's called an extraneous solution. Right? It worked out through the algebra, but it does not make sense as far as the problem is concerned, because when we checked it and plugged it in, we got a false statement. So that's known as an extraneous solution. Alright, let's check out the one where m is equal to 5. So that one's thrown out. We don't use that, we don't circle that, we don't box it in. Negative 3 plus 5 plus 59 equals 5. Negative 3 plus 59 and 5 gives us 64. And then the square root of 64 is 8. And negative 3 and positive 8 make 5, which is equal to 5. That's a true statement. So I'm going to go ahead and box that one in and say, yes, that is my answer, m equals 5. And that's my only answer. If you're taking a test or an exam, you're not going to let your teacher or instructor know that m is equal to negative 10. You'll cross that out and maybe let them know that it is an extraneous solution, and also let them know that the only solution is m equals 5. That is the only solution. So this is why the checking portion or the checking step was very, very important in solving radical equations. So it's a must, and that's why we wrote it at the end as the very last step. All right, I hope this helped you, and if it did, please hit the like button. Please feel free to share with your friends, family members, classmates, or anyone else who may need this information, and hit subscribe. And also feel free to shoot me an email if you need any more topics gone over. Take care. Have a good day.